Good afternoon. I came to know that most of you have not followed 7 segment display interface programs. Have you all followed how to construct 7 segment code given with any character? So some character is to be displayed. So for example, I want to display character A onto the screen. How actually you are going to construct the 7 segment code? If this is the character you want to display, for character A, what is the 7 segment code you are going to construct? If it were to be common anode type and common cathode type. Have you all followed? Do you want me to tell it again to construct the 7 segment code? Yes or no? You have to interact, otherwise, it will be difficult to follow. Can anyone tell whether you're able to understand the construction of 7 segment code for the given data?
Yes, ma'am.
That is a digit or an alphabet. Okay. So if it were to be, say, character A you want to display, you know how actually you're constructing 7 segment code. See, this is what the character. These are the segments you want them to glow. Okay. So that is segment A, B, C, then here E, F, and then G. Only these characters must be glowing. Rest other these segments must glow. Rest other segments must not glow. And as I told, there are two conventions to construct the 7 segment code. Taking H as the MSB or taking A as the MSB, you can construct the 7 segment code. Okay. So just write the 8 bits H, G, F, E, D, C, B, A. You just have this 8 bits and see whichever segment must be turned off, take its status as 1. So H segment, it is the dot that should not glow, that's why we shall take H segment status as 1. Then D, it should not glow, that's why its status we are taking it as 1, and rest other segments values will be 0 since they must be glowing. Okay, then what is the value you are going to get for A? To display letter A, it is 0x. It is an hexadecimal code, 8-bit code. It is 88. This is the 7 segment code what you have constructed. 1 0 0 0 1 0 0. It is 88H. So if you are taking A as the MSB, what will be the 7 segment code that will be constructed for displaying letter A onto the display interface? So just have the bits in this order: A, B, C, D, E, F, G, H. Okay. And here only H and D bit must be turned off. Rest other bits must be on. So that since it is common anode type, we are going to work in the lab. That configuration of 7 segment display. Whichever segment must glow, that status we are going to take it as 0. And for turning off the segment, its bit status is 1. So what is this value you are going to get? 0001 means it is 1. 0001 it is 1. So if you are taking A as MSB, the 7 segment code for letter A you'll get is 11H. Getting? This is how you are constructing. Hope this is clear. For letter A, there are two 7 segment codes we can construct. Considering H as MSB, A as LSB, this is the 7 segment code you are going to get. Taking A as MSB and H as LSB, 11H will be the 7 segment code. Both are valid. So depending on which bit you have taken as MSB, this is what the result you are going to get after you construct the 7 segment code. So whatever may be the convention you follow, either H as MSB or A as MSB, what you have to remember is always you have to send the bits in this order: H, G, F, E, D, C, B, A. Whether it is A to H or H to A you have constructed, always you have to send H bit first, then G bit, then F bit, E, D, C, B, A. In this order only you have to send the data bits. So what is the code we have written is, so once the 7 segment code is constructed, we'll start with H bit. We need to test whether this bit status is 1 or 0. Depending on that, we either will send 0 or 1 through port 0.15. You know the significance of IO DIR register. it is used to control the direction. So port 0.15 is configured as an output port. Using this port pin, we are going to send out the data bits. So we have written the logic to test whether H bit is 0 or 1. Once you come to know that it is 1, we'll send out 1 through this port 0.15 pin. Otherwise, we'll send out 0 through port 0.15 pin. So once H bit testing is completed, we'll go for testing G bit and so on. So this process will repeat 8 times. Since in a byte code, that is 7 segment code, which is a byte data, totally there are 8 bits. We need to test each of these 8 bits. So how many iterations are required? It is 8 iterations. Are you getting? So now we shall see. Now, hope you have understood the construction of 7 segment code. Let me just implement the program once again. So I think you got confused once I wrote the user defined functions first, then the main function. If you are having confusion with that, let me just start with the main function first, and then I'll be discussing the user defined functions. So what is the problem if you are defining first the main, then the user defined function is, you need to have the declaration statements of the function. Since compiler will not be knowing what is that function, you cannot simply make a call to the function within main without telling the compiler what is the name of the function, what argument the function receives and all. So that information you are providing to the compiler through the declaration statement. So if I write the user defined functions first, then the main function, so declaration statements can be skipped. So that is the reason I have just implemented first the user defined function, then I went for implementing main function. Okay. So if you are getting confused with that, let me start with main. Let us go in order. So what is the first statement? And remember, all part B programs are C programs what you are going to implement. So what should be the extension of the file? Any C program you implement or you create, it will be .c extension. So part A programs, you will be saving the file with extension .asm or .s. But part B programs, you will be saving with the extension .c. Is this clear? See, I've used the Keel software. I cannot execute this program since interfacing component is not connected. Just to show you the statements, how we are writing step by step, just I'm showing the inline coding. I think that would be better. You'll clearly understand. Okay. So what is the extension of the file you are going to take? It is .c. Since it is a C program, it is the procedure is same. You need to create, once you open the project, you need to create a new file, going to the file menu, and then you'll save that file with .c extension. You need to add that file to the source group. So one more thing is, whenever you are executing part B programs, that startup code that is also required for executing part B programs. So as soon as you create a project, it asks whether to add the startup code or not. You kindly add that. If it is not there, if you are not able to add it, add existing file to the source group. In that you can select and you can just go for adding that startup code. Okay, you can browse and you can add it later also. So see that startup code and .c file both are in the source group for only part B program execution. Okay. So now this is what the extension for the file you need to give. What is the first statement you are going to write in any embedded C program with respect to LPC2148 microcontroller? If you are coding or if you are implementing any program on LPC2148 microcontroller, what is the first statement you are going to write? Now you have to tell me the code.
Include LPC214x.h.
Right? Hash include. Let me first write hash include. So kindly try to analyze each and every statement what I am writing. So if you are still having any problem, you can let me know so that I'll try to make you understand. Okay. Hash include lpc214x.h. Okay. So this is what the header file we are including. Why we are including this header file? We'll be using the registers, right? LPC2148 registers through their name you are using. So all the registered definitions you find in this header file. You can simply refer to the registers of LPC2148 through their names. So we are going to write IO dir, IO set, IO clear, IO pin, etc. So the register pin select. All these registered definitions you find in lpc214x.h header file. Okay. So 21xx.h also you can give. Main thing is lpc21. This header file name is required. So once this header file is included, now we shall go for writing the main function int main. And how many functions I'm going to define for each of those 7 segment display programs? One function named write segment. for displaying a character onto the 7-segment display interface. Character may be a digit or an alphabet. So any one character, if you want to display, you require this routine. And it is no compulsion that you need to write a separate routine for performing that operation. Everything, if you want to include the main function itself, you can. But that doesn't improve the readability. So since it is a separate operation, I'm trying to make it more meaningful by having it as a separate function. You know the advantage of having function, right? So that is the reason I've taken it as a separate function, that is write segment. If you want to write that complete code, whatever I had written in write segment within the main function itself, you can do it. It's all left to your implementation. You already know C coding. Just make use of that knowledge to interface 7-segment display to LPC2148 microcontroller. That's all. Okay. So what are the routines we need to implement? One is write segment. Other one is delay routine. These are the two routines I have to implement. So what is the return type of those two functions? I have taken the return type as void. Since that function is not going to return any value to the calling function, return type will be void. So since I'm now what I'm doing is I'm defining the user defined functions later. After the main, I'm going to define. That's why declaration statement is compulsory. So what is the declaration I need to give? Void, name the return type of the function. Then I'm going to give write segment. Okay, write segment. This is the name of the function. And what argument the function receives. What is the argument the function is going to receive? Write segment function. Is it a character data? 1 byte data it is, no. I can take the data type as unsigned char, okay, say X. I need not give the variable name here since it is just the prototype. If you are giving variable name also, it is fine. It is optional to give in the declaration. You know that. This is the function prototype statement I am going to have for write segment. Void return type, name of the function I have given it as write segment. Okay, or if you want to give it as display character, that is also fine. All left to your implementation. This is user defined name, you all know. Within parenthesis, the data type of the argument that is received by write segment is unsigned char. Okay. Now, one more function I have to declare, that is delay. We need to introduce some delay so that the information stays for some period of time. Whatever the information you have displayed onto the 7-segment display interface, to make it stay for some period of time, we are going to make a call to delay function. So what is the declaration statement for delay function? Return type is void, name of the function is delay. Within this, what is the argument it receives? So we are going to take unsigned integer. So some 10,000 is the value I'm passing to delay routine. So I cannot hold it in that data in a character variable. So since 0 to 255 is the range of values we can represent using unsigned character, let us take the data type for delay argument as unsigned integer type. Are these declarations clear? Return type for write segment is void. How many arguments write segment function receives? Just one argument. What is the data type we have taken? It is unsigned character. Why it is so? Since the 7-segment code, it is an 8-bit code. So for that, unsigned char data type is sufficient. So delay routine, we are going to introduce some amount of delay. So value I have passed in all the programs, whatever we have discussed, it is around 10,000. So that's why we are taking it as unsigned integer type, the argument which we are passing to delay routine. Clear? Are able to follow? So you have to respond in between, otherwise it will be difficult for me to interpret whether you have followed or not. Okay. Have you followed till this?
Yes, ma'am.
Okay. Now we need to take an array. I told any information you want to display, you have to construct a 7-segment code, and that code should be initialized in the memory. So here, first program of your lab syllabus is you need to display 0 through F. It is not just one character you are displaying. So series of characters you need to display on the 7-segment display interface. So if it were to be only one character to be displayed, no need of taking an array. You know the reason why we go for array. The same type of elements, if you want to store multiple elements of same data type, we are going for arrays. So here, to store the 7-segment code for the characters 0 through F, we are going to take a variable named data. So that is an array which is holding all the characters to be displayed onto the 7-segment display interface. So now we shall have that in the memory. First two statements within the main are declaration statements. If you are defining user-defined functions after main, this is required. But if you are going to define user-defined functions before main, you can skip these declaration statements. Hope I am clear. So I've just separated function declaration with variable declarations within the main function by giving a new line here. See, I'll give unsigned, then char, since each is a byte data, we are going to store in this array. So character type variable I have taken, that is data. Since size is unknown, if you know exactly what is the size, since we will be knowing it is all set, what values you need to initialize in the memory, you will be knowing. If you want to give the size, you can specify, or else you can just leave it blank. Whatever the value, number of values you are going to initialize, accordingly it is going to occupy the space for the variable data. It is all basic concepts which you have learnt in C. Okay, now opening flower base I need to give. Here I need to give list of 7 segment codes, whatever I need to initialize. Now tell me, so what is the data we need to display? It is 0 to F. 0 to F in rolling fashion I need to display. Okay, so here this is what the value we need to initialize in the memory, that is in that array. I need to initialize 4 blanks. So just remember this. 4 blanks I need to initialize. After that, 0 to 9. In sequence, I need to initialize the 7 segment code for 0, 1, 2, 3, 4, okay, 5, 6, 7, 8, 9. Why 4 blanks initially? Since once I execute the program, 7 segment display interface program, what I have to see initially on the 4 digit 7 segment display? All the segments must be in off state. So in all of the, or in each of the 4 digit 7 segment display, none of the segment must glow. So that means, so initially, what are the 4 characters you need to send to the 7 segment display interface? It is FFH, so that none of the segment will glow. So that's why you need to initialize in the memory this data. Then 0 to 9 and then F, A to F, okay, A, B, C, D, E, F. You have to decide the pattern. See, one thing, kindly let me make it clear. Kindly remember, you first decide the pattern in which you want to display the data. Once that pattern is decided, then you can initialize in the memory these 7 segment codes. Okay. As per the question, it is 0 to F I need to display. And what is the pattern I want to display is, first I need to display all blanks. That is, none of the segment must glow. It is a 4 digit 7 segment display interface. Okay. You know that already, that interface diagram is discussed. Okay. So this is the 4 digit 7 segment display interface we are having, right? So initially when I execute in this 4 digit 7 segment display interface, what data should appear? It is all blanks. None of the segment must glow. So it will be 4 blanks. After that, what should I display? 3 blanks. Then 0 should appear at the least significant 7 segment display. Then 2 blanks, 0, 1. Okay. Then 1 blank, 0, 1, 2. In this order, it has to display. Okay. Next, 0, 1, 2, 3, and so on. So in the memory, this is the order in which I need to initialize the 7 segment code for each of the characters. So let me give that as a comment. Okay. If you are having confusion, you write a comment in your program like this. See, 4 blanks. After that, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then A, B, C, D, E, F. And then again I need to give 4 blanks. Okay. So since it is rolling fashion, I can end with only 3 blanks. That is sufficient. Since in rolling fashion, I'm trying to display. If you are having this command, you can easily know for which character I need to construct the 7 segment code. So first, just observe what are the sequence of characters I have given in the command B. So B means it is blank here. It is not character B are displaying. It is blank. That's what I have represented as B here. So to make or to turn off each and every segment in the 4 digit 7 segment display interface, I need to send FF. How it is FF? Are you able to analyze that? How it is FF? See here, it is a 7-segment display. None of the segment must glow. You know the segment, how they are named: A, B, C, D, E, F, G, and dot is H bit. You take, as I told, the convention I have followed throughout is taking, we have taken H as the MSB. H, G, F, E, D, C, B, A. This is the 8 bits we have taken. Just observe, none of the segment must glow means what should be the bit status? It's all one, right? Since it is active anode type or common anode type, none of the segment must glow. That's why the bit status we are going to take it as 1. What is this value? 1111 means it is F. 1111 means it is F. What is the 8-bit 7-segment code you are going to get to turn off each of the segment? It is FFH. Correct? Have you followed?
Yes, ma'am.
Okay. See, what is the first? Just observe the comment and match it with the values what we are initializing in the memory in this array. See, 0xFF I'll give. 0xFF, comma. Then again I need to display for at a time I can display only 4 characters since it is a 4-digit 7-segment display I'm using. So 4 blanks I need to give. 0xFF, comma 0xFF, comma 0xFF. 4 blanks are displayed. Next, they are initialized. To display 4 blanks, I have initialized in the memory the 7-segment code for 4 blanks. So next 7-segment code I need to initialize is for 0. You construct the 7-segment code. Depending on what information you want to display, so you try to construct a 7-segment code. For 0, I need to construct a 7-segment code. Only G bit and H bit should be off. Rest other bits must be on. So for considering this, H as the MSB, what will be the code for 0? Just see. So it for G, it is 1. And for H, it is 1. For rest other, it is 0. Since rest of the segments must glow. What is this value? 1100 means it is C. 0000 means it is 0. What is the 7-segment code for displaying 0 you got? It is C0H. So what you do is, in the memory, 7-segment code you initialize. It is 0xC0. Okay, C0. This is what you initialize. So similarly, you need to construct a 7-segment code for rest of the digits. For 1, what is the 7-segment code you'll get? It is F9H. 0x F9. Do you want me to show for rest characters or you are able to follow? Shall I write completely the code correctly? Just to improve the readability, I have just given it in a separate line. F9H is a 7-segment code for 1. 0xA4, it is a 7-segment code for 2. 0xB0, okay. B0 is a 7-segment code for 3, which I have already shown in the class, okay. And then for 4, so what is the 7-segment code for 4? 0x, it is 99 for displaying 4. For any digit, if you have not followed, let me explain. Kindly let me know whether you are following or not. Okay. 0x. So this is for 4. For 5, it is 0x92. So how it is 0x92? So that you can decide. See, 5 I need to display. This is how I want to display 5. Okay, which are the segments that must be glowing? A, C, D, then this is F and G. Correct? These segments must be glowing. How it is 92? Take that. H, G, F, E, D, C, B, A. D, C, B, A. Take the bits. Okay, named like this. And now A must be, whichever segment that should not glow, its bit status must be 0. E bit, its bit status must be 1. E bit status is 1. Okay. Then H bit status is 1. Rest other bits, then B. B status must be 1. Correct? Just see, B should not glow, E should not glow, and H bit must not glow. Only these bits status will be 1. Rest other bits, G must glow, F must glow, D must glow, C must glow, and A. So what is this value? See, 1001 means it is 9. 0010 means it is 2. 92H. This is the 7 segment code you have got. 0x92. So in the same lines for each of the characters, you can decide. So for displaying one, if you want to make this segment glow, you can do it. Okay. These two segments, if you want to make it glow, you can, or these two segments. It's left to your implementation. What 7 segment code you want to construct for displaying one. So taking either you can make only F and E segments glow, or you can make B and C segments glow. Any one you can consider, and you can construct the 7 segment code. Are you getting? Okay. See. So this is the 7 segment code for 5, whatever I showed. Then for 6, it is 82H for displaying 6. Then F8, the 7 segment code for 7. Then for 8, what is the 7 segment code? It is 0x80. For 9, it is 0x98. Then for A, it is 0x88, which I have already shown. And for B, 0x, it is 80 for B. Okay. And then for C, it is 0x C6 for C. For D, it is 0x C0. D, it is like, it looks like O. Okay, capital D means it looks like O. Then E, it is 0x86. And for F, it is 0x8E. After that, I want to display 3 blanks. We need to consider 3 blanks. For displaying blank, you know the 7 segment code. That is FF. 0xFF, 0xFF, 0xFF. Have you understood this declaration? Unsigned char data, it is an array. This is what the sequence of characters 7 segment code I have initialized in the array. Okay. Totally, how many characters 7 segment code we have initialized? Say 4 blanks. 4. Then 0 to 9. 10 digits. 14 plus 15, 16, 17, 18, 19, 20, 21, 22, 23. So totally 23 characters 7 segment code you are finding in this array. Is this declaration clear? Have you all followed? Still any doubt? Followed or not? If you want to give this all initializations in the same line, you can give it. It will be lengthy. That's why I've given it in new line. That's all. Followed?
Yes, ma'am.
Hope you are not having doubt in this declaration and initialization statement. Coming to the variable declaration, I will be using nested loop. That's why I require 2 loop control variables, one for the outer loop, other for the inner loop. I'm going to declare it now. Unsigned. Okay. Unsigned char I comma j. 2 loop control variables we are declaring. So next, to enable GPIO functionality for a port, which register must be configured? Which is the register that is to be configured to enable GPIO functionality? Can anyone tell? Before performing the communication between LPC 2148, that is before sending the data bit, you need to configure some registers. Which are the registers I have to configure? Any program I discuss on any of the interfacing component, what is the procedure? Whatever may be the component you are interfacing to LPC 2148, which are the 2 registers I have to initialize first? Can anyone tell those 2 registers? Which are the 2 registers? Recall and tell me which are the 2 registers I have to initialize. Any interfacing component it may be. These 2 statements are compulsory in the main function. The first statement, as I told, any port you are having, maybe port 0 or port 1, it is meant for general purpose bidirectional IO operation only. but it's a good programming practice to initialize that register I had told. What are the two statements after declaration you are going to write before proceeding further with the operation or with the communication statements? What you have to write after declaration of the variables? Which are the registers I have to configure? No one. Are you not following? Can you name the registers which we have discussed with respect to LPC 2148? 32-bit registers we had discussed, no? 32-bit registers. Can you name those? At least name the registers which we have discussed for LPC 2148. Come again. IODIR. Before to that, I had discussed one register. Pin select, right? Yeah, pin select. PINSEL. Pin select. IODIR. IO set. Right? IO clear. IO CLR. Okay. And then IO pin. Remember these 5 registers given with any question on interfacing you can easily implement. Can't you remember these 5 registers which are supported in LPC 2148 microcontroller? Each is a 32-bit register. How many pin select registers are supported? It is 3. 3 pin select registers are supported. 2 IODIR registers, 2 IO set registers, 2 IO clear registers are supported, and 2 IO pin registers are supported in LPC 2148. How the registers are numbered? So I told there are 3 pin select registers. How they are numbered? It is pin select 0. If you just suffix 0 to it, it becomes pin select 0 register. Pin select 0, pin select 1, pin select 2.
And pin select 2.
IODIR. There are 2 ports. With respect to those 2 ports, we are having IODIR 0 and IODIR 1
And
register.
1.
Yeah, IO set similarly to IODIR, IO set 0, IO set 1. 0 indicates it is for port 0. 1 indicates it is for port 1 with respect to these 4 registers. Exceptional cases, pin select. Rest other, if you are suffixing 0 to these registers, that means that register is associated with port 0. If you are suffixing 1 to these registers, then what it means is that register is associated with port 1. Hope this is clear. But pin select, it is 3 registers supported in LPC 2148, where 0 and 1, pin select 0 and pin select 1, these are associated with port 0. These 2 registers are associated with port 0. Pin select 2, it is associated with port 1. Okay. So how to control the functionality of lower order 16 pins of port 0? So which register I need to configure if I want to control the functionality of lower order 16 pins? Port 0, it is P0.0 to P0.16. 15. Lower order 16 pins. How the higher order 16 pins are numbered? P0.16 to P0.31. 31. Okay. So this is lower order 16 pins of port 0. This is higher order 16 pins of port 0. If I want to control the functionality of lower order 16 pins of port 0, which register I need to initialize or configure? It is pin select 0. Okay, pin select 0 to control the functionality of lower order 16 pins of port 0. Pin select 1. This register is used to control the functionality of higher order 16 pins of port 0. Are you getting? So pin select, each of these pin select registers are of how many bit? It is 32 bit. So that means 2 successive bits. So how the bits are numbered? Let me write it. Let me just clear it first and let me write it. See how the bits are numbered, you know. Bit 31, bit 30, okay, and so on. And so on. Here we'll write bit 3, bit 2, then bit 1, bit 0. So this is how we can number the bits in pin select. I'm talking with respect to pin select register. Pin select, assume pin select 0 register I am configuring. So how this pin select 0 register is a 32-bit register, you know. This is how we can number the bits. Bit 1 is the least significant, bit 0 is the least significant bit. Bit 1, bit 2, bit 3 and so on till bit 31. It is total of 32 bits. It is a 32-bit register. Okay. And the bits are paired. Remember, the bits are paired. So those details are not required for you since we are dealing with only GPIO functionality. You need not worry about this. But if you are having knowledge of this, then you can code with confidence. That's all. Okay. See, bit 1 B not. Bit 1 and bit 0. These are paired. Bit 3, bit 2 are paired. Similarly, 4 and 5 are paired. The bits, then 6 and 7 are paired, 8 and 9 and so on, 30 and 31. Like this, bits are paired, successive bits are paired. So bit 1 so bit 0 and bit 1, whatever the status you write in the pin select 0, that will control port 0.0 pin. Okay, so 2 and 3, whatever the data you'll write at position 2 and 3 in pin select 0 register, it will control which pin? Port 0's 1. P0.1 pin can be controlled by writing to these 2 bits. Okay. Similarly, the functionality of P0.2, if you want to control, right, we need to write the data to bit 4 and bit 5 position. So similarly, P0.3 and so on. So this is to control P0.15. Okay. So 0 through 15. So it is 32 bit. Half of the pins we can control using pin select 0 register. Since to control each pin, 2 bits are used. So how many pins can be controlled using 32-bit register? It is 16 pins. Yes or no? We can control 16 pins
Yes,
of a port by using a 32-bit register since bits are paired here. So since only 2 bits are used to control the functionality of the particular port pin, how many functionality we can provide? 2 bits means what possible values we can have for 2 bits is 0, 0, 0, 1, 1, 0, 1, 1. These are the only possible values we can have given with 2 bits. So here, this is the first functionality for any pin we can have. So if we take that particular bit pair value as 0, 0, that means it is the GPIO functionality we are going to, that particular pin is going to provide. GPIO. So say bit 0, bit 1. If I take this bit status as 0, 0 in the pin select register, okay, 0, 0, that means P0.0 can act as a GPIO port pin. And that means I can perform IO operation through this pin, input and output. So if I take 0, 0 at bit 2 and bit 3 position, okay, bit 2 and bit 3 position 0, 0, that means port 0.1 can be functioning as GPIO port pin. So if I want all the 16 pins, lower order 16 pins of port 0 to function as GPIO port pin, what I should write to pin select 0 register? What is the 32-bit data I have to write? 32-bit data. 32-bit data. It is 0, 0, right? Pin select 0 is equal to 0x. I need to write 8 zeros. Yes or no?
Yes,
Are you
ma'am.
getting? You
Yes,
want
ma'am.
me to write in detail the bits? 4, 5, 6, 7, 8,
All ports
9,
will function as
10,
GPIO.
11, 12, 13, 14, 15, 16, 17, 18, see, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So what is the equivalent hexadecimal value for this? It is 8 zeros, 8 hex zeros. So these two to configure port 0.0 as GPIO port pin. These two to configure port 1. Okay, this is 0, 1 to configure 2. This is to configure 3. This is to configure port 0.4. This is to configure 5. This is to configure 6. Okay, just see if you are taking 0, 0 for that bit pair, it is configured as a GPIO port pin. What do I mean by GPIO? So all the ports they are meant for IO, right? What for you are using ports? For IO communication. That means input output operation. So if you want to send out, if a microcontroller wants to send out the data to an IO device, it can send it, or some data need to be received by the microcontroller. So these IO operations can be performed by using ports. Two ports are supported in ARM, that is in LPC2148 microcontroller. Okay, so by default, what for the ports are used? Totally two ports are supported. Each is a 32-bit port. What is the purpose of port? For IO operation, input and output operation. Okay, microcontroller, you can take that as one component, and an IO device, okay, as another component. If you want to have communication between microcontroller and IO device, so there should be ports supported by the microcontroller for IO operation. So input, that is into the microcontroller, output out of the microcontroller. For controlling this or for having this communication, we are having two ports in LPC2148 microcontroller. They are named as port 0 and port 1. Are you getting? So by default, ports are meant for IO operation. But it's a good programming practice to configure pin select register to make the particular port function as a GPIO port. So if you are writing 0, 1, it is having a different meaning. If you are writing 1, 0 to that particular bit pair, it is having a different meaning. Since it is out of the scope of the syllabus, we are not discussing the other functionality of the port pin. We are discussing only GPIO functionality. So to make lower order 16 pins of port 0 function as GPIO port pins, I need to write in all bit places value 0. Okay, it is 32-bit data. This is what I need to write. Pin select 0 is equal to 0x 8 hexadecimal zeros. That means since to pin select 0 I am writing this data, lower order 16 pins of port 0 will be configured as a GPIO port pin. If you are writing the same data to pin select 1, that means you are making higher order 16 pins of port 0 as GPIO port pins. What about port 1? Which pins are available for operation in port 1? Yes. Which pins are available for port 1? Can anyone tell?
Higher order 16 bits.
Higher order 16 bits, right? Higher order 16 bits, 16 pins of port 1 are available for operation. So pin select 2 register I need to use, pin select 2. So if I write 0 to this pin select 2 register, then in that case, the higher order 16 pins of port 1 will be configured as GPIO port pin. Are you getting? Have you
Yes, ma'am.
followed till this? So
Yes,
what are the two statements we have to write? Any interfacing program is given, any question on any of the interfacing component. So as soon as you do the declaration in the main function, first go for writing the data to the pin select register. Depending on which register or which port pins are used for communication, you need to make use of that particular register. So since in for 7-segment display interface, we are dealing with which register? It is port 0 register, port 0 port only. Port 0 only, that port we are using for communication between LPC 2148 and 7 segment display. So if I configure pin select 0, that is sufficient. I need not worry about pin select 1 and pin select 2. Why not pin select 1? Since which are the port pins? If you just recall that 4-digit 7 segment display interface, which are the port pins that are used? One is P0.15 to send the data bits. Other one is P0.2. Only these pins which are in the lower order 16 pins of port 0, right? Yes or no? See? Are you able to
Yes,
understand?
ma'am. Yes, ma'am.
Okay. So sports I'm using for interface. Let me write that pin number P0.15 and P0.2. So for communication, only these pins are required. Actually, these pins are appearing at the lower order 16 pins of port 0 or higher order 16 pins. It is lower order, right? So that means I need to write that is 0 to pin select 0 register. I'm not worrying about higher order 16 pins of port 0 since that is not at all used for 7 segment display interface. Correct. So that's why what we are going to do is we are going to write pin select 0 is equal to 0x. I'll write all zeros. Actually, if you just write 0 for 50, that is bit 30 and bit 31, and which is the bit number for P0.2. If you are writing for 0 for only these bit pairs, that is sufficient. For 15 to configure it as GPIO port, bit 30 and bit 31 status must be 0, correct? And what about P0.2? 0 and 1 for the port 0.0, 2 and 3 for 1, 4 and 5. This bit status must be 0. Rest other bits we are not worried at all. But in common, just to make it easy, what we have done is all the bits in pin select 0, we have made it as 0. What you have to see is actually 4th and 5th bit in pin select 0 and 30 and 31. So you need to check out whether these bits are 0. Since I need to configure P0.15 and P0.2 to function as GPIO port pins. Yes or no? Correct?
Yes, ma'am.
So, but
Yes.
why to worry about other bits? Anyway, other bits, other pins are not at all used. Why we need to worry about other bit status? Let us write 0 for all the bits in pin select 0. It will also configure that is P0.2 and P0.15 as GPIO port pins. So all the lower order 16 pins of port 0, we are trying to configure it as GPIO port pin by writing all zeros. Just for our convenience, we are writing all zeros to port 0 pin select 0 register. See, pin select 0 is equal to zeros. If you are using port 1 register, port 1, that port if you are using, make use of pin select 2 register, write all zeros to it. What we want is for all interfacing programs, it is GPIO functionality. When I say IO interfacing, we are discussing, we want ports to act as IO ports, input output operations we want to perform. So the data we are going to write to pin select register, irrespective of the register you are using, 0, 1 or 2, we'll write all zeros. Remember this. Is it difficult to remember this? Are you getting? If you are dealing
Yes,
with
ma'am.
port 1, write all zeros to pin select 2 register. If you are dealing with higher order 16 pins of port 0, just write all zeros to pin select 1 register. We did not worry about other bits. So let us configure all the lower order or all higher order pins of a particular port, that is port 0, as GPIO port pin. Even though you don't write this statement, if you comment and execute, your program will work fine. Why? Since the ports are meant for IO operation. But as I told, it's a good programming practice to do this. This is left to you, whether you write or not, where to configure pin select register. So when it will be useful is if you want to make that particular port pin function for different purpose, maybe for serial communication or for any other operation. If you are using that port pin, whatever the functionality defined for that particular port pin, if you want to perform that operation, then pin select register will be having some significance. But since it is all IO operations we are performing in part B, Even though if you don't give the statement, your program will work fine. Am I clear? Getting? Okay. Shall I proceed?
Yes, ma'am.
So pin select 0 is equal to 0x00. Since each statement in C must be terminated by semicolon, let us give semicolon. Next register, we need to set the direction. Whether it should that particular port pin must function as an input port or output port. Accordingly, I need to set the direction. It is IO dir register I have to use. And since we are dealing with only port 0, which register I have to use? Specific IO dir register. It is IO dir 0. This is the register I need to configure. What value I need to initialize? It is port 0.15 and port 0.2. Only these two pins we are using in port 0. Only those pin values must be 1. So IO dir 0 is also a 32-bit register. So what I need to do is see bit 31 must be, so this value must be 0. Bit 30 must be 0. Bit 29, 28, 27, 26, 25, 24, 23, 22, 21, 20, 19, 18, 17, 16. 15th bit must be 1. Then 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So this is the value you need to load to IO dir register. Let me separate the nibbles so that it improves the readability. Okay. See. What is this hexadecimal value I need to load to IO dir register? Just observe. This is bit number 15. Let me write the comment. So whichever I have made 1. So this is actually port 0.15. I want to make 15th bit as 1 and this is bit 2. This is B2 bit which is made as 1. In IO dir register, if I make, okay, if I am going to make 15th bit and second bit as 1, what it means? Can anyone tell what it means if I make 15th bit in IO dir and as 1 as well as second bit in IO dir as 1? If a 1 in a IO dir register, if you find, what you can infer? What 0 indicates and what 1 indicates? In IO dir register, IO dir direction control, GPIO direction control register. If you are writing a 1 to the bit, what it means? If you write 0, what it means?
If it is 0, it is input. If it is
1, it is output,
1,
right?
it is output.
So
Yes,
yes,
ma'am.
port 0.15 and port 0.2, I want to make these two pins as output port pins. That's why I'm taking at that bit position value 1. Rest other bit positions I'll take it as 0. What is this 32-bit hexadecimal value you'll get? Just write for each nibble, write one hex digit. What is the hex digit you'll get? 0000, then 8004. Correct? Yes or no? What
Yes,
for
ma'am.
we have written the statement IO dir 0 is equal to 0x00008004. Here we are setting port 0.15 and port 0.2 as output port pins. Are you getting output port pins? For doing this, we have initialized IO dir register. Correct? Hope the statements are
Yes,
clear now. This is
yes,
what
ma'am.
we have done so far in main. We have done the declaration of the functions. Function prototyping is done. Then array is initialized, declared and initialized for the 7-segment code which we want to display onto the display unit. Then we have declared the loop control variables. The first state, the executable statement we are going to write is pin select 0 is equal to all zeros. So since we want to configure lower order 16 pins of port 0 as GPIO port pins, then IO dir 0 equals 0x00008004 I have initialized since I want to make port 0.15 and port 0.2 as output port pins. These are the two statements you are going to write depending on which port you are going to use as well as which port pin you are going to configure. Pin select will initialize and IODIR register will initialize. In each of the interfacing program, these two registers will initialize first. The main function, any main function you see in whatever the programs we are going to discuss, these two statements will be there. Okay. Now let me write. So whatever the operation we are performing, that should be running infinitely. We are going to create an infinite loop like this, while always it will be true. That means the statements whatever I write within a while loop will be executed infinitely. So we are running the loop from. This is the outer loop header I'm going to give. I equals to 0, I less than 20, I plus plus. This is the number of times I want the iteration to take place. So why it is 20, I've already told. How it is 20? Just see. So first I need to display these 4 characters. That means as soon as I execute the program, 7 segment display, I also showed the video where you are seeing all blanks initially, right? After that, what will be the output? How actually the digits are getting scrolled? How we are seeing that illusion as if digits are getting scrolled from right to left, right? So first, how many characters? First 4 characters. What will be the data? Just see in the array here. 4 blanks will be displayed. After that, I need to increment I. Initially, I is 0. Starting from 0th position in the array, if you try to access 4 characters, so what will be those 4? All FFs, right? That means initially none of the segment will be glowing in the 4-digit 7 segment display. At a time, we can send, we can display 4 7 segment codes or 4 characters we can display. After that, in the next iteration, if I increment I index will be 1. So starting from position 1, if you access 4 characters, okay, these 4, what is the meaning? 3 blanks and it is code for 0, right? Are you getting? Each
Yes,
time
ma'am.
I is incremented and from that position we are trying to access 4 information, 4 byte data we are accessing. In the next iteration, I will be 2. Starting from this position 2 in the array, we are accessing next 4 7 segment codes. We are sending each of the code bit by bit. 4 characters you need to send means 32 clock pulses you have to apply, so that those 4 characters, those 4 7 segment codes what we have taken from this array, that will be that equivalent character will be displayed onto the 7 segment display unit. After sending 4 characters, we are introducing some delay, so that pattern will be there. You can see that pattern for some period of time, so that it simulates the rolling fashion. So once I becomes 3, starting from FF, we are accessing next 4. If you want me to write it in the same line, you can write like this. Totally 23 7 segment codes are initialized. I've counted correctly. So this is an array consisting of 7 segment codes. So we'll take 4 at a time. So these 4, next I'll take next 4. Okay. So what is the pattern I'm going to display? So first I want 4 blanks. After that I want 3 blanks, then 0 to be appeared at the least significant 7 segment display unit. Then 2 blanks, 0, 1. Then 1 blank, 0, 1, 2. Then 0, 1, 2, 3. Then 1, 2, 3, 4. Then I need to see this pattern 2, 3, 4, 5. Then I need to see 3, 4, 5, 6. Then 4, 5, 6, 7. Okay. Then I need to see 5, 6, 7, 8. Then 6, 7, 8, 9. Then I want to see 7, 8, 9 A. This pattern I want to see. Then I want to see on the 7 segment. So this is a simulation of rolling fashion. Then I want to see 8, 9 AB. Then I want to see 9 ABC. Then ABC blank. Sorry, D and since till F I need to display. Then BCD E. Then CD EF. Then DEF. Okay. then blank. Okay, blank I need to display, then EF 2 blanks, then F 3 blanks. After displaying F3 blank, that means at the most significant 7 segment display, we'll display F and rest will be blank. After that, what I want to say is all blanks. If I repeat the loop, since it is infinite while loop, then again it starts from 0th position while 4 blanks will be displayed. So this pattern is repeated infinitely. So what are those patterns? These are the 20 patterns that will be displayed. Okay. First, starting from 0th position, these 4 characters are considered, which displays 4 blanks. Next, I is incremented to 1. From 1, next 4 7 segment codes are considered. So it displays this pattern on the 7 segment display, that is 3 blank 0. Next, I incremented to 2. From here, 4 7 segment codes are taken that are sent to the 7 segment display. Totally 32 clock pulses are applied so that this pattern gets displayed. That is 2 blanks and 1. If you just try to analyze this pattern, it is simulating rolling fashion. Are you not feeling digits are getting scrolled? I have also shown the video. Okay. How many iterations are considered here? It is 20. If you make a count of these iterations, okay, it is in total 20. Yes or no? This is 20 iterations. Okay. This you have to decide based on what information you want to display. You have to decide these, decide the number of iterations. Accordingly, you have to initialize in the memory the 7 segment code for that data. So this is the pattern I have initialized in the memory. Okay. Are you able to understand why outer for loop is running from 0 till 20? I equals 0, I less than 20, I plus plus. How many iterations are required to show this rolling fashion? 20 iterations. So what you are displaying in each iteration, that I have shown individually here. 4 blanks, 3 blanks, 0, 2 blanks, 0, 1 and so on. Is this clear? Yes or no? Still are you having any doubt?
Unclear.
Clear. See, now the inner loop. This is outer loop is to decide the number of iterations. I know it is 20 iterations required. In each iteration, how many digits I need to display? Just see. How many digits? In each iteration, how many digits I have to display? See the pattern, individual patterns and tell me how many digits I have to display in each iteration. How many digits I have to send? 4 digits, right? Digits, not the segments I'm telling. So this is first iteration output I want to see. Second iteration output is 3 blank 0. Third iteration output is 2 blank 0 1. Fourth iteration output is blank 0 1 2. Fifth iteration output 0 1 2 3 and so on. So in each iteration, how many digits I am sending to 7 segment display? Yes? Or how many
4.
characters? 4 characters, right? That is controlled through inner loop. Outer loop to control the total number of iterations. Inner loop to control the number of characters you want to display onto the 7 segment display. So we shall run the inner loop with j as the loop control variable. J is equal to I. Okay. J less than I plus 4. Starting from ith position in the array, I need to access 4 characters. That is 4 7 segment codes. So I plus 4 I need to give. If you just give j is equal to I, j less than 4, your code will not work. I plus 4 should be the condition. Yes or no? J plus plus. If initially I is 0, starting from 0th position, 4 7 segment codes you are accessing means FF, 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 FF. These are the 4 7 segment codes you are accessing. Once I takes the value 1, 1 plus 4 means till position 5 in the array you are accessing the next 4 characters. Data present at first position in the array, second position, third position, and fourth position. Once once j becomes 5, the inner loop will be terminated. This is what the data you are displaying in the second iteration: 3 blanks and a 0. Are you getting why we have written these conditions? Test condition part in for loop, outer for loop, and inner for loop. Still anyone not followed? Outer for loop, this is to decide number of iterations. Number of iterations, which I have shown here, 20 iterations. This is number of characters to be displayed. Number of characters to be displayed. And this is same for all the programs on 7 segment display. Since it is a 4-digit display interface we are using, at a time we can display 4 characters only. So number of characters to be displayed will be always 4. So inner loop is running from j is equal to I, j less than I plus 4, j plus plus. I need to access the array. That I am passing as an argument to the function write segment. Single line statement we are going to write within the write segment of, so the name of the array I have given it as data of j. Inner loop index, whatever you have given, just give that index, semicolon. Okay. First to the write segment, which is the 7 segment code I am going to send first. That is first blank, FFH. Then j gets incremented to 1. 1 is less than 4, control enters. Then we are sending the 7 segment code of FF. The data present at position 1 in the array is FFH. 0, 1, 2, 3. Whatever the data present at these index values, 0, at index 0 you are having FF, at index 1 FF, index 2 FF, and index 3 FF. So a loop is executed 4 times, 0 to 3, with j value as 0 to 3, to access these array elements. Each of these 7 segment code is sent to write segment function. So for displaying each of these 7 segment code, okay, we require 8 clock pulses. So in write segment, you are trying to write the code for displaying a particular character. So after the inner for loop terminates, that means once 4 characters are sent to the 7 segment display interface, we are trying to introduce delay. We'll make a call to delay routine. Delay of, will specify some value. It depends. Whenever you go for execution practically, you'll come to know how much delay is required. If you feel that the data bits, the characters are getting scrolled too fast, you can increase the delay so that it will be moved slowly. You can control it through your code. Okay. So let us assume this much delay. If you want, you can make the changes to the delay. Since it is theoretical code you are writing, you can introduce any delay. You can write any value. It is no compulsion that you have to write this value. Just to make the information stay for some period of time, whatever displayed onto the 7 segment display, this is what the delay we are introducing. Just we have made a call to delay function, which we'll define later. Just that's all. Close the outer for loop and close the while loop. Then just give return 0 and close the main function. Okay. This is the main function we have written. Declared the function. We have declared an array and we have initialized it with 7 segment codes. We have declared loop control variables ij. We have configured pin select 0 register. We have configured IODIR 0 register based on which port pins we are using. Then this is the infinite loop we have written, within which we have written the code. Nested for loop we have used. Outer for loop is to control the number of iterations, and inner for loop for number of characters to be displayed. And in inner for loop will be repeated 4 times. Outer for loop it is 20 times repeated. Okay, 0 to 19. Inner loop it is starting from I value. Only 4 times inner loop will be executed. For each of the inner loop value, write segment function is called with j value taken as an index for array. Whatever the 7 segment code extracted from the array, that is passed as argument to write function, write segment function. Okay. Then delay we have introduced after sending 4 characters, we are introducing delay. Close the for loop and close the while loop, return 0 and close. Followed the main function. Did you all followed main?
Yes, ma'am.
So now right segment, I think you have followed right segment function. See void, return type is void. Just see the declaration statement what I have given. Accordingly, we shall write the function header. Right segment is the name of the function I have given. Right segment. Then it receives one argument. It is unsigned char, say x. Any name you want to give to the variable. What x receives is the 7-segment code. You can see rate data of j. If j takes the value 0, ffh is the first code that is retrieved from the array. At 0th position in the array, you are having ff. ff is received by x, variable x, the 7-segment code. And now what we have to declare here, we shall declare unsigned char I, the loop control variable. Now we need to run the for loop. Since it is 8 bits for each character to be displayed, we are having the loop header as for I equal to 0, I less than 8, I plus plus. Okay. So in right segment, why this for loop header, you know. In the 7-segment code, it is an 8-bit code. Since all the 8 bits we have to send to display any character onto the 7-segment display interface. And here we need to just write the conditional construct if x and it is bitwise AND operation. What is the mask value by which you need to perform AND operation? Since h bit is to be tested first, I'll take 0x80 right shifted I times. If you are getting confused with this expression, you can test it whether it is not equal to 0 or equal to 0. If you want to use relational operator, if x and this expression double equal to 0, you can write data to IO clear register. Else, in the else block, you can write data to IO set register. Not equal to also you can use. If you are aware of this expression x and based on the result of evaluation of this expression, if condition will work, right? If this expression evaluates to false, control will go to the else block. That is, if it evaluates to 0, control will go to the else block. Since if 0 means condition is false, control has to go to the else block. If non-zero means control will go to the true block of the if statement. Yes or no? You already know this, how if works. Okay. If this is non-zero, to IO set register we have to write IO set 0 is equal to what value I have to write? What is the value I have to write to IO set register? Can anyone tell? If you write 1 to IO set register, what happens? Yes. So which pin is configured as an output port pin to send the data bits? Which is the pin? Port 0.15, right? You need to send out the data bits through port 0.15. So just write IO set 0 is equal to 0x 0000 8000. We are sending 1. So only in the IO set 0 register, 15th bit is made as 1. Rest other bit status we are making it as 0. So if you are writing 1 to IO set register, that means that port pin will be having logic 1. If you are writing 1 to IO clear register, then that particular port pin will be having logic 0. Whether it is IO set register or IO clear register, you are writing 1. That means if you are writing to IO set, logic 1 will be the status at that port pin. If you are writing to IO clear register, logic 0 will be the port pin status. 0, writing a 0 to IO set or IO clear, it is not having any significance. Okay. So this is send 1. Send logic 1 via port 0.15. Else, if this expression evaluates to 0, then control will go to the else block, where what we are going to configure IO clear register. IO clear 0 is equal to 0x 0008000. What we are doing here? Send logic 0 via port 0.15. Are you able to understand this if else block? Can you kindly respond?
Yes, ma'am.
Okay, now after sending one bit, either 1 or 0, as I told, since internally shift registers, cascaded shift registers you are finding, you need to clock in the data. So that's why you need to apply the clock, high to low pulse you have to apply. So for that, we need to write 1 to the IO set register at bit position 2. And again, we'll write 1 to the IO clear register at bit position 2. Since to apply the clock, port 0.2 pin is used. So what we'll do is, in common to if else block, after if else block is written, we are writing IO set 0 equals 0x. Just take 1 at bit position 2. 0000 will get 0004. At position 2, you are taking 1 means the hexadecimal value, the nibble, the least significant nibble value will be 0100, which is hexadecimal 4. If you want still more clarity, you can write this 32-bit data in binary and you can verify only bit 2 is 1. So we are sending, what is the meaning of this? Send logic 1. Logic 1 via which port pin? Port 0.2. Okay. So now I need to send 0. To send 0, logic 0, which register I need to configure? It is IO clear register, right? IO clear 0 equals 0x, same value. Whether you send 0 or 1, I told 1 is to be returned to that appropriate register. 0000 I'll write. What is the meaning of this value? We are trying to send, okay, logic 0 through which port? Port 0.2. Okay, try to analyze this 32-bit data. 0000 so 8, 12, 16, 20, 24, 28, 32. This is the value I have initialized here. See, this is bit number 2. This is bit 2. Whose status is 1. Rest of the bit status is 0. So 0000 means it is hexadecimal 0. Okay. Just see. Next 0000, it is again hexadecimal 0. This is hexadecimal 0. Least significant nibble is 0100. What is the hexadecimal value? 0100 means it is 4. Just observe, in IO set 0, we have written 4. How it is 4? Since bit 2 is used, since port 0.2 is configured as an output port to send out the clock pulse. I need to write at second bit position value 1 to IO set register. At the same bit position, I need to write 1 to IO clear register, so that logic 1 and logic 0 are sent out through port 0.2 respectively. Did I made it clear? Are you able to follow?
Yes, ma'am.
Close the for loop and close the function. So this is what the function we have implemented for write segment. So totally 8 times this for loop is executed. Each time we are, by what mask value we are testing, that is we are performing AND operation. For H bit 80H, for G bit it is 40H, for F bit it is 20H, and so on. Since we are performing right shift operation by I value, each time in each iteration I is getting updated. In the first iteration I value is 0, 80H is the mask value we are taking, since we need to test H. Then 40H will be the mask value. Since 80H right shifted one time will result in 40H. That is the mask value you are taking to perform AND operation, so that we can test G bit and so on. After testing, we'll infer whether it is 1 or 0 to be sent out. Accordingly, if you want to send 0, I'll write to IO clear register. If I want to send logic 1, I'll write to IO set register. Either of these two operation will perform. So it is two-way branching. After that, this is in common to if else block. We are going to send the clock pulse, high to low clock pulse. First I'll write to IO set, then I'll write to IO clear. So if you have clearly understood right segment routine, any question given on 7 segment display, you need to write this right segment routine code. It is common since to display a character onto the 7 segment display, this is what the code required. One more function is left out, delay. I'll quickly go through that delay and we'll stop. A delay routine, delay of unsigned int I have given. I told this is just to kill the time we are defining this function. Void delay of unsigned int x I have given, and within which I am declaring one more variable, unsigned, okay, int I, and here we are going to run the loop. I have given an outer loop as while loop, while x minus minus, and within this is a nested loop where we have written. If you want to have nested for loops, that is also fine. For I equals to 0, I less than some 250 are given, I plus plus semicolon. What do you mean by this? If you want to give semicolon to the for loop header itself, you can give, or if you want to give semicolon in the next line, that is also fine. What do you mean by this? It is do nothing. Don't perform any operation. Semicolon means we have not written any statement. We have simply given, we have terminated that statement with semicolon. That means don't perform any operation. This is called as null statement in C. Do nothing. How this code will work? For loop, as I told, semicolon can be given to the for loop header also. The meaning is same. To make it more meaningful, I have given semicolon in the new line. Just observe what happens. If x, assume x value is say 5. Let me consider for tracing x value as 5. Okay. And how many times, see how this nested loop is working. This is post decrement I have used. First it tests whether 5 is non-zero. Yes, condition is satisfied. Control enters the while loop. And until the inner for loop gets terminated, it will be in the for loop itself. Yes or no? You know how nested loop works. I equals to 0. 0 is less than 250. Yes, it is true. And since control enters the for loop, there are no statements to execute in the for loop. It is null statement. After this, where the control will go? It goes to the updation part where I is incremented to 1. 1 less than 250 is tested. Yes, it is true. It enters. It doesn't perform any operation. It simply goes the updation part. So that means control will be executing the condition part and then updation part, and it repeats until this test condition fails. That is I less than 250. Once it fails, control will go to the outer loop where it decrements x. Okay. So x is already decremented. The current value of x will be taken. Then it decrements x. So this process is repeated. So for each value of x, inner for loop will be executed. Okay, this is just to kill the time. Here in the outer loop, we are doing decrement operation. In the inner loop, we are doing increment operation. Increment, decrement operations we have used to kill the time. That's all. What is there in this to understand? I'm not getting why you people have not followed this delay loop. This is the complete implementation of the first program of your lab syllabus. Right segment routine and then the delay routine. Okay. To avoid this declaration statements, I had first defined this user-defined functions, right segment and delay. At the end, I had given the main function, so that we can skip these two declaration statements. Have you all followed? Still any doubt in this?
No, ma'am.
Okay, all of you. What about others? 16 students have joined. What about rest? Have you all followed in detail? I have told.
Ma'am, can I explain that for loop inside a right segment function?
For loop, this one, right segment.
Yes, ma'am.
This one. Shared clearly.
I was set 0 and IO clear.
IO set and IO clear. See,
Yes, ma'am. What happens when it is assigned value?
I have written this complete 32-bit data, right? I was at 0 is equal to 0000 8000 means what is the binary value? This is 4, 8, 12, 15. This is 1. These bits are 0. This is the binary data, right?
Yes, ma'am.
Let me write it here as a comment. See here, 0x, 4 hexadecimal zeros means 4 nibble values will be 0. Then 8 means 1,000,000. Then again 0000. In all rest 3 hex digits are 0. That means rest 3 nibbles will be 0. Correct. So which
Yes, ma'am.
bit in IO set register I have made 1?
15.
Count the bit number.
Uh,
Count the bit number.
15, ma'am.
Bit 15. Correct. Why bit 15 only? Bit 15. Why it should be written one at bit 15 position only? Why not other bit position? Which are the pins you are using for 7-segment display interface? Which pins you are using?
Ma'am, P0.15 and P0.0.
No, P0.2, right? P0.2 for applying the clock pulse, leave it. In the if else block, we need to just send the data bits either 0 or 1 through P0.15 only. Okay. P0.2, you can see in this statement, to apply the clock pulse, we are using P0.2. P0.15, see logic 1 and logic 0 you have to send out through port 0.15 pin only. That means 15th bit in IO set register, we are taking its status as 1, rest other bit status as 0. So if you write 1 to a IO set register, that means that port pin status will be logic 1. You are sending, the microcontroller is sending out logic 1 to the 7-segment display through port 0.15 pin. That is the meaning. Are you getting?
Yes, ma'am.
Okay. Then IO clear register. See, you are performing this operation in the if header. If this expression evaluates to 1, non-zero value, then control will enter the true block where we are writing 8000H to IO set 0 register, meaning you are sending logic 1 through port 0.15. If this expression evaluates to 0, assume the bit which I am testing, it is 0. Performing AND operation with 1 will result in 0 only. The result of this AND operation will be 0. So control will go to the else block where it executes the statement IO clear 0 equals 8000H. What is the meaning here? Same data we are writing to IO clear register. 0, 0, 0. This is 1, 0, 0, 0, 0, 0, 0, 0, 0. If you are writing at bit 15 position value 1 to IO clear register, that means a logic 0 is sent through port 0.15. So whether you are writing, you want to send logic 1 or logic 0, which registers we have to use? If I want to send logic 1 through particular port pin, I need to write 1 to the IO set register. If I want to send logic 0 through a particular port pin, I need to write 1, okay, to IO clear register. Since the register name is clear, you should not write 0 to that port pin, to that bit. You have to write 1 only. But what finally is sent out through that pin, it is logic 0. If you are writing 1 to the clear register, logic 0 will be sent out through that port pin. Are you getting?
Yes, ma'am.
Still, are you people getting confused? See, it's online, no, it's very difficult to make you understand. Since will not be having any interfacing component, as far as possible, I've tried to make you understand. Still, anyone is having doubt? Are you able to follow this?
Ma'am,
Hmm.
if that logic is on, that LED will glow, right?
Which one? No.
If that
Logic 1 means if you are sending one to common anode type configuration 7-segment display, how that segment will
oh,
glow?
okay, it will not glow. If it is sent zero,
After
it will glow,
sending
right?
all the 8, if you send 0, it will glow. We need not worry about whether it will glow or not. After sending 8 bits, okay, of that 7-segment code, you will see a character appearing on the 7-segment display unit. Okay.
Yes, ma'am, got it.
First we are sending H bit, then G bit, FE, DC, BA. After you send all these 8 bits, whether it is 0 or 1, okay, you know how we have constructed the 7-segment code. Assuming common anode type configuration of 7-segment display you are using, you have constructed a 7-segment code. Whichever segment you want to make it glow, you have taken its bit status as 0. The segment to be turned off, its status you have taken it as 1. So that code you are sending bit by bit through port 0.15. If the after testing the bit, if you find 1, then that means actually that segment should not glow finally in your 7-segment display. Once you output all the 8 bits, what you'll see is if H bit is sent first, assume H bit is sent, which is logic 1. When you see finally the H bit status, it will be not glowing. Yes or no? Since H bit is 1, we have taken. Are you getting?
Yes, ma'am.
Okay, 0 bit, if you are sending 0 bit, that means whichever segment value you are sending, that segment will be glowing and the final output. Still any doubts? Still anyone is having any doubt? See, these programs are
No,
very
ma'am.
simple. In part B, you can easily score uh, a complete one. Any question given, it will be all simple in interfacing questions. Embedded C programming you will get. You can easily score in Unit 5. Okay. Can you able to, with this knowledge, can you try to analyze the second program, whichever I have discussed? Yes, can you try attempting writing the program for that second one without looking into? You try to write the code. You try to analyze. Can you do this? Can you try this? If you are not getting that second program, some other time I will try to explain if required.
Yes, ma'am.
With this knowledge, if you are able to understand, that is fine. What about others? Can you give the feedback?
Ma'am,
Now
we
it's
tried.
clear.
Clear? Okay. You can try to take your own data and try to simulate in rolling fashion or left to right to left, whatever the program questions are given. You take your own data and try to do the modification to your program. Once you come offline, you can try with that code whatever you have written, and you can check your output whether it's working or not. You'll get confidence. Clear? Try to do that. To replace the code, whatever we have given, the data to be displayed on 7-segment display, you change the code and what changes to be made at different position in the program, wherever you require, what changes to be made, you check out, make the corrections and keep it with you. So that you can execute practically and you can check the results. If it were to be practical executions, I would have made you to execute the programs by making the changes. But since we are in this situation, I'm not able to do that. As far as possible, I try to make you understand through the slides and through the traces. Is it fine? Shall we stop here?
Yes, ma'am.
Okay.